We walk into buildings every single day and just trust that they're safe, that they won't collapse. But that trust isn't blind. It's actually engineered. It's built on a whole set of hidden rules, a kind of unseen blueprint for safety. And in this explainer, we're going to pull back the curtain on that very blueprint.
All right, so here's the plan. First, we'll dig into the fundamental ideas that actually keep buildings standing. Then we'll meet the invisible forces they're constantly up against. We'll also see how buildings are designed not just to be strong, but to fail safely, which is super important. After that, we're heading to a boot camp to see how materials get tested. And finally, we'll wrap it all up and see why these rules are so critical for all of us.
So our whole story really kicks off with one key document. It's the official rulebook for structural safety in South Africa, SANS 10400 Part B. This is the master plan, the foundation for everything.
I mean, it sounds like such a basic question, doesn't it? But the answer is this incredible mix of science and engineering, and it really all comes down to a few powerful principles at the very heart of this standard.
And boom, there it is. This one sentence is basically the mission statement. These 4 words are everything: strength, stability, serviceability, and durability. You need strength to handle loads, stability so it doesn't just tip over, serviceability so it's actually usable day to day, and durability so it lasts. Simple as that.
Now, to make all this practical, the standard gives us something called deemed to satisfy rules. And the recipe analogy is just perfect. If an engineer follows this pre-approved recipe using the right materials and methods, the building is automatically considered safe. No need to reinvent the wheel every time. Okay, so if the standard is the hero of our story, then every hero needs a villain, right? Well, in this case, the villains are the invisible forces, or actions as they're officially called, that are constantly trying to bring a building down. So an action is basically any force a building has to deal with. That includes the obvious stuff, like the weight of the building itself, the people inside, all the furniture. Those are called direct actions. But it also covers the sneaky stuff, the indirect actions, like the ground shifting, or even just temperature changes making things expand and contract.
And this is where you see this isn't just some generic one-size-fits-all rule book. A huge chunk of South Africa is built on what's called dolomite land, which is notorious for sinkholes. That's a massive risk. So the standard has entire sections just for that, tailoring the rules to very real local dangers.
The rules also have to think about the slow burn threats. Take this coastal area, for instance. The air is so humid that condensation can actually form inside the walls. Now, over years and years, that moisture can cause rot and rust, totally compromising the structure. The rules make designers plan for this from day one. So we've met the enemy, these actions. Now let's look at our hero's powers. How does the standard make sure buildings can actually stand up to these forces, not just for a year, but for their entire lifetime?
It all comes back to these 4 pillars, and it's a balancing act. You can't just have a super strong building that's unstable, and what good is a durable building if it's not serviceable? You know, if the floors vibrate like crazy or huge cracks appear everywhere, they all have to work in harmony.
The standard is also really practical about how long things are meant to last. It says the core structure, the bones of the building, should have a design life of at least 30 years. But for things that naturally wear out, like the roof covering or windows, it sets a 15-year life, because everyone knows they'll need to be repaired or replaced eventually. Okay, now this is one of the most important ideas in modern engineering. It's called preventing disproportionate collapse. What it means is, if one small part of a building fails, let's say a single column gets hit in an accident, it won't set off a catastrophic domino effect that brings the whole building down. The damage is contained. It's a huge safety feature. And look at this level of detail. The standard doesn't pretend buildings will stay perfect forever. It actually plans for reality. It defines what's an acceptable amount of minor damage, right down to the width of a hairline crack. This all goes back to serviceability, making sure the building performs well without freaking people out over normal cosmetic stuff. All right, now for the fun part, the physical tests. This is where theory meets reality. To prove that materials are actually strong enough for the job, they get sent to a kind of building boot camp, where they are pushed, smashed, and slammed to their absolute limits. First up, we've got the soft body impact test. This is designed to simulate, say, a person accidentally falling hard against a wall. To do that, they swing a heavy sandbag like a pendulum and slam it right into the test wall. And this isn't just any sandbag.
The standard is super specific. It has to be exactly 30 kilograms. That precision is key because it means the test is fair and consistent, no matter who's doing it.
Next, we have the hard body impact. This one uses a heavy, sharp steel tool to mimic things like dropping a heavy object or accidentally kicking the wall. It's for those sharp, sudden impacts. For walls in high-traffic areas, this test delivers a really focused impact of 7.9 joules. To give you a sense of that, it's roughly the same energy as dropping a brick from about shoulder height onto a tiny little point. It makes your walls can take a beating.
Yup, even something as ordinary as slamming a door has its own standardized test.
For this test, they use a standard 25-kilogram door. They swing it from a 60-degree angle and slam it shut 10 times. This makes sure the wall and the door frame can handle that repeated stress over and over again without falling apart.
So, we've gone through the rules, the forces, the boot camp, but let's just zoom out for a second. Why does a document that's full of technical details actually matter to all of us? Well, it all boils down to one simple thing: confidence. At the end of the day, this rulebook isn't just a list of do's and don'ts. It's a powerful tool in the hands of a competent person, a registered professional engineer. It gives them a proven framework to make smart decisions and ultimately to take responsibility for the safety of every person who will ever step foot in that building.
And that really leaves us with one final big question. This standard isn't set in stone. It's a living document. It gets updated to deal with new materials, new construction methods, and new challenges like climate change. So the blueprint for safety is never really finished. The real question is, how do we keep evolving it to make sure it's ready for the buildings of tomorrow?